for this first one, we have -2, -7. We're checking in both of these. So if I plug -2 in for x, what's 3 times -2? -6 minus 1? -7. So is that yes or no? Yes. Okay, if I plug in -2 to this one, what's -2 times -2? 4, and then plus 4? 8, so not -7, right? So this is going to be a no. All right, if I plug in 0, what do I get for this equation? -1, so that's going to be a no. And if I plug in 0 for x in this one, what do I get? 4, so it's going to be yes. Okay, if I plug in 1 to this one, what do I get? 2, so that's a yes. And then if I plug in 1 to this one, what do I get? 2, so that one's a yes. Any questions on that? Okay. Okay, so then for number 2, it says, now graph both equations above on the coordinate plane below. At what point do they intersect? So let's graph this one, 3x minus 1 first. So where do I start my line? Yep, -1, so they will intersect, right? And what's my slope? 3, so that means I do what? Up 3 over 1. Okay, and then this one will graph. Where do I start that line? 4. And my slope is -2, so how do I move? Down to over 1. All right, so it asks where your two lines intersect. So what point is that at? 1, 2. Okay, so something that I want you guys to notice. So when you're checking a point in an equation like this, like plugging the x into to get and looking at the y to see if it works, what you're essentially doing is trying to see if that point is on the line. So like if I were to plot that point, if it's going to be on the line that you have graphed. Does that make sense? So if it's a yes, that means it's on the line. If it's a no, then it means it's not on the line. So what was the only point here that was on both lines? 1, 2. And where did these cross? 1, 2, right? So that's the only way that a point can be on both lines is if like the two lines are crossing at that point. Does that make sense? Yeah? Okay. So that's going to be the only point where you're going to get a yes, yes, is that one single point where it crosses. Okay? All right, so we are doing systems of equations this unit. So we're going to learn 3 methods to solve systems depending on like how the problem's given to you. So the first method is graphing. So your objective is students will be able to find the solution to a system of equations using a graph. So all of our solutions or answers are going to be points, x comma y, okay? So a system of equations, just to define that, is a set of 2 or more equations. We're only going to do 2 equations this year, and then in Algebra 3-4, you guys bump it up to 3 equations, and those problems are like whole board problems. So it's 2 or more equations. So basically the idea is that you have 2 relationships between x and y with the 2 equations, and that's enough to be able to figure out what x and y equal if you have 2 relationships, okay? The first method, the graphing method, the way we handle that is we always graph the lines and just see where they cross. So your solution is going to be x comma y. It's going to be that intersection point right there. And then we have 3 different types of solutions that we're going to come across for all of the methods. 99% of the ones that you're going to get are going to be this first one. And that's where you have one solution, meaning an x comma y. You're going to get a point where they cross. If you end up with parallel lines, that's going to be no solution, because you have to kind of think logically. If my solution is where the lines cross and the lines are never crossing, then I'm not going to have a solution, right? Yes? Okay. The last kind is infinitely many solutions, and that happens when you take your two lines and you graph them and they end up being the exact same line right on top of the other one, okay? So because the idea is that like every point is a crossing point then, because they're right on top of each other. So it's infinitely many, okay? Good? Okay, so we are going to practice today graphing in whatever form the equation's given to us in. If you want to convert them to y equals mx plus b every time, you're more than welcome to, but that's just a lot of work if you have a simpler way of doing it, okay? So let's just go for it. So the first one, I'm going to graph. So what is these are y equals mx plus b, so what's my y-intercept? 2. And my slope? Yep, 1 over 1. And for these, I usually do my line like the whole way across because you have no idea where the crossing point's going to be. So you wanted to make sure that you have everything covered. Okay, and then for this one, what's my b? 2. And my slope? 3 over 1's up 3 over 1. All right, and then I can see where they cross. Right here. What's that point? 2, 4, yeah. So that would be your solution. And I'm going to show you just one time on this problem how you could check it if you wanted to. Like if you're not 100% confident in your graphing abilities and you think you got the answer, but like you just want to make sure that it's the right answer, you would basically do it the same as the warm-up. So you would do, take both equations, y equals x plus 2, plug in x and y, 4 equals 2 plus 2, so 4 equals 4, so it checks out. That's a yes in the first one, and it has to be a yes, yes, it has to be in both, okay? So then check the second equation, y equals 3x minus 2, plug in the x and y, 4 equals 3 times 2 minus 2. And then go ahead and figure out what that would equal. All right, so what's 3 times 2 minus 2? 4. Yep, so you get 4 equals 4. So that one checks as well. Okay? So that's if you wanted to just make sure that your answer is correct. But you don't have to do that every time, obviously. Okay? Just if you wanted to, you know how. Okay? Any questions? Cool. Will you guys go ahead and do the next one? Oh, 3 over 1.
3.
Yeah. It's just a fancy 3. All right, ready? All right, so for the top one, what's my b? And then my slope? Yeah, 2 over 1. All right, and then what's my b for this one? 2. And my slope? 1 over 1. All right, so it looks like you get this point right here, which is what? Negative 2, 0. Yep. Mm-hmm. Yeah, where they cross, yeah. Good? Okay, so this is basically, it's the same thing all the way through. The only thing that's going to change is that we're going to have different forms of the line. So if you're dead set on making it y equals mx plus b every time to graph it, be my guest. You're just going to be spending a lot more time on this than other people might, okay? So I'm going to graph it in whatever form it's given to us in because we learned a different method for every single one. So for this first one, this is in what form? 2x minus 3y equals 6. Standard form. Yep. So do you guys know how we graph something that's in standard form? What do we use? Mm-hmm. Yep. And then what's that going to give us? Like what are this called?
The 2 points.
Almost. In. Mm-hmm. Yep, the intercepts. So I'm going to cover up the y basically. So I have 2x equals 6. So what is x equal? Mm-hmm. And then cover up the x to find the y. So I have negative 3y equals 6. So what does y equal? Negative 2.
Don't you do like the 2 points? Like it would be like 0,
Yeah. I'm just not going to put the 0. Yeah, but that's, yeah, so it would be 2 separate points. So yeah, not the same one. And then from here, once you have those, you can count to get like more points if you want for the slope. So it's up to over 3. So then just keep doing that. Up to over 3. And then what form is this bottom one in? Yeah. So you're basically putting 0 in for the other one. So it disappears. So like here, if I put 0 in for y, that whole piece is going to disappear, so I just have the 2x and the 6.
So I would always put a 0 for the y.
If you're trying to find the x, yeah.
Okay.
And then when I'm trying to find the y, then I put 0 in for the x, so then that just disappears.
Oh.
Does that make sense? Okay. So what form is this one technically in? Yeah, so point slope form. Think about this as like y plus 0 or y minus 0 equals negative 2/3 x plus 3. That's why it's not there, because it was just a 0 for that coordinate. Okay. And then remember, for the point that you pull out, it's opposite because it defaults as subtraction in the formula. So what's my x coordinate going to be? Negative 3. And my y coordinate? So plot that point. And then from there, same thing. What's my slope? Negative 2/3. So I'm going to go down to right 3. And I get an intersection point right there. And what's that at? 0, negative 2?
No. Wait,
Yeah?
0,
Okay. 0, negative 2. Good? Mm-hmm. Did you flip the negative 3, 0? Yeah. All right, let's work on the next one. All right, for the top one, that's in standard form. So what would my x-intercept be? 4. And then I would have 2y equals 4. So what does y equal? 2. Yes. Okay, so we're there. And we can count out the slope down to over 4. So that's like down 1 over 2. And then the bottom one is in point slope. So what would my point be? Yeah, negative 2, negative 1. And then what's my slope? All right, so that point is what? Good? Any questions? Yeah. Because the original formula is x minus x. So in order for the subtraction to turn to addition, a negative had to be put in. All right, so for this next one, y equals 4x plus 3 is in y equals mx plus b. So what's my b? 3, and then my slope? Start at 3, up 4 over 1. All right, and then for the standard form, we have negative 3x equals 6. So what does x equal? Negative 2, yep. And then negative 3y equals 6. So what's y equal? Negative 2, yep. So we have negative 2 for the x, negative 2 for the y. That's like down 1 over 1. All right, so we cross right here at negative 1, negative 1. Good? Any questions, guys? No? Okay. Go ahead and do the next one. Mm-hmm.
Right there in problem 3, it says negative 3x equals 6, and it says x equals negative 2. How do we
Divide 6 by negative 3. All right, on this one, for the intercepts, we have 2x equals 8. So what does x equal? Yep. And we have negative 4y equals 8. So what does y equal? 2. Yep. Okay, so it's up 2 over 4. So it's like up 1 over 2. Okay, so there's that line. The other one's in y equals mx plus b form, so what's my b? 5, and my m? Yep. Okay, so start up at 5, and then down 3 over 1. All right, so your solution looks like it's right there. Where's that at? 2 negative 1. All right, any questions? Okay. Okay, next one. So we have, for this one, we have negative x equals 2. So what does x equal? Negative 2. And then we have 2y equals 2. So what does y equal? 1. Up 1 over 2. Great. And for the other line, what's my b? 1, and my slope? Start at 1, up 1 over 2. Okay, so what do we notice? Yeah, but it's the same exact line, right? So it's crossing at all of those points, so it's infinitely many solutions. Then you guys are doing that last one. All right, so for this top one, what's my b? Yep. What's my slope? Okay. And this line, what's my slope? Or my y-intercept? -1 and my slope? So what do we have? No solution. Yep, because these are what kind of lines? Parallel lines, yeah. All right. Good. Do we have any questions about that at all? Wait, I'm give on my desk. Thank you. Wait, just throw it on my desk because I'll throw it in with this and lose it. All right. Lesson check problems. Okay. Take a minute to get those done.
Use the restroom. Thank you.
Okay, I'm gonna put answers. All right, this one you should have 2, 5. This one's no solution. -1, 0. And -1, -3. Any questions? No? Got it? Pretty easy. Okay, cool.